Hello, everyone. Hello to the online people too, because it's live stream. So today's topic is built on top of Angular signals. I'll start with a little bit of history, things that we already know. And the first one is dependency injection. All of us, of course, know what dependency injection in Angular is. And in order to do dependency injection before, we should or always needed a constructor and a class, or some, let's say, use factory in our injection tokens. And of course, we can just inject any kind of service using, I don't know, protected user profile state, and we put the class as a, let's say, type there. And Angular will do its job inside, let's say, its compiler and convert those things to something else. And of course, dependency injection was tied to classes only. You couldn't use them anywhere else. And something happened. In V14, Angular released a function called inject. Not released, just made it public. It was always there because that's what Angular has always been using internally for the constructor injection. It just compiled everything to inject under the hood. And of course, we could just now use inject to do dependency injection. Now we can use them in guards that can be just functions. We don't need a big class with a @injectable that we don't know if we need to provide it in root or not for a guard or an interceptor. And of course, basically inject is the modern way to access DI. It simplifies class components, class component inheritance, and of course enables us to have function-based and composable features, and we'll see about that today. Inject is also now the recommended option for doing dependency injection since V20. Providers. Well, we have environment providers. Everything that we put in the providers array in Bootstrap application is an environment provider. And of course, every component inside our application will have access to it. It's like doing provided in root. And of course, in modules, we also have the providers array in there too. And every component in that module will have access. But it's not just components, it's also other providers that we provide there, or directives, pipes, and everything else. And of course, now we also have route providers that are also environment providers scoped to that route only, and all its children, let's say, routes. And lately, I've seen this pattern used a lot. Now we don't have an issue with, let's say, providing services in our components anymore, because of some patterns that have, let's say, been used or showcased lately in the community. Okay, so we have this kind of providers, mostly Bootstrap application providers, ng module, component directives providers, route providers, and of course, good old provided in root. Yeah. Okay, why the intro to injection and providers? Well, because we have to know when an injector scope gets destroyed. Why is that important? Well, because most of the time, we provide something, and inside those services, or let's say injection tokens, we may register some listeners, or some subscriptions, or a set interval, or a set timeout. And if a provider or injection token never gets destroyed, so its instance never gets destroyed, then what happened is that we basically will have a never-ending set interval, or a never-ending subscription. And those are so easy to, let's say, forget. And this way causing sometimes also memory leaks. So we have subscriptions, DOM event listeners, and timers, things that most of the time will cause issues when you forget about them, if you don't unsubscribe. Sometimes also in SSR if you're doing a migration in there. And in order to do, let's say, cleanup, most of the time we used ng on destroy on components. And of course, ng on destroy is only usable on classes, like components, directives, pipes, but also sometimes services that are provided in some component. So we cannot use them in functions. We cannot do cool stuff with them. We couldn't, I have to say. And we can say that we couldn't reuse cleanup logic. We couldn't do it because we were tied to classes only. In order to do cleanup, we would have to extend the class in order to properly, let's say, reuse code somehow. And then DestroyRef comes and basically unlocked a lot of things. And we'll see all about it in a minute. So DestroyRef is a token that basically provides us access to the destruction lifecycle of injection token or injector scope. So think of it like if you inject it, it will tell you when its injector gets destroyed. So we have DestroyRef that we can use with inject now, of course. And inside the constructor, we can just say this.DestroyRef.onDestroy, and inside of it, we can provide any cleanup logic that we need. I just console log something. For example, if we have a user service and have some user history variable, and after that we subscribe inside constructor, we store the subscription in a variable, and then inside our DestroyRef, we can just clean it up. So we co-locate code. So basically, having inject and DestroyRef has unlocked a lot of possibilities for Angular, because just like we can co-locate code in the same place, we can just move it out completely. For example, we can just say inject some external state, have, let's say, inject also DestroyRef, because we need that token. We can say create some state, subscribe to some external one, because there's always async stuff to do. And then, of course, inside DestroyRef, we can clean up and return the state that we have, all in the same place. And of course, easily use it, as we have seen a lot of patterns lately. So, a core thing is that we make sure that all the subscriptions are cleaned up, because we always clean up, even though we call them inside functions. The injectable there, it's not provided in root, so it's still tied to its, let's say, provider scope or injection scope. So if you provide it in Bootstrap application, that subscription that you may have there probably will never get cleaned up. So we can reuse cleanup logic through the application without having to use inheritance, and that's a big win. And I have to say that almost every new API that Angular has released that subscribes to something or gets something asynchronous uses that pattern. Effect, resource, form, signal forms. After next render, every render effect, HTTP resource, Rx resource, whatever, to signal and to observable. Everything uses inject and DestroyRef. So back to the previous example with user history, we can do the same thing. We can just set some state, subscribe to some observable, and return that state. And of course, use it as a normal variable, say user history, inject some user history. But we have that thing called user history there that's just a normal array. But if our subscriptions emits again, our parent component that uses that function won't get notified. Of course, that will only be updated once. And what's the last piece of the puzzle? Any idea? Say it louder. Signals, yes, it's signals. Signals and reactivity. Basically, we all know signals, I hope at this point. Who has no idea about signals? Raise your hands. Come on, one? OK, good. I love it. So we have signals. We can create them. We can derive them using computed. And of course, using the effect, we know that when they change, something will be executed. And of course, we can update them in, let's say, macro task queue. Otherwise, they will just be coalesced into one update. And signals, of course, improved something called change detection. Last year at NGD, I gave a talk about signals change detection in Angular. I highly recommend it if you haven't seen it yet. And basically, it had this core slide there. With signals, Angular can just change detect or synchronize only the component that changed and nothing else. So the whole componentry doesn't have to be checked if you're using onPush. And if you only one signal change, only that component will have to update and nothing else. And that's so cool. But Angular doesn't just do change detection anymore. It does a lot of other things. So it's a normal framework, again, I have to call it. It's called synchronization. Let's say we have a component that says double. We show a double computed. And then when we click, we increase a count that double depends on. And if we compile it to some imaginary JavaScript or just normal JavaScript, like we create two variables, count signal, count double, which is a computed, and then we do some document create element. That's something almost what Angular does under the hood, and except the effect part. So basically what we do is we create elements, append them to the body, and of course inside the effect, every time our double component changes, the effect calls itself, it updates the text content. So basically the same idea, but with just JavaScript and signals. So what I want you to think is that think of the template as it's running inside an effect. Every time a signal changes inside an effect, what you know is the effect will run, basically updating our template, or in our case, updating DOM. So basically, Angular is a framework that synchronizes signals to the DOM. Nothing else. Or not. So synchronization basically updates the DOM view based on signal state. Now let's say we have an input. So we have a count, and of course we use it as an input value, and of course we have a change event listener that updates our count when it changes. Let's compile it to JavaScript again, and basically that's what we will have, something like add event listener, some change, and update that count when the event emits. And of course, because we have the effect, it will always update the value. So we can do better, of course, because as we saw, that's a lot of code for one basic thing. And ng model. Who loves ng model? OK. All your reactive forms? OK. OK. With ng model, what we can do is basically put a signal inside of it. Don't have to call it, and it just synchronizes. Nothing else. And that's perfect. Because the framework speaks in signals. It says, give me a signal, I know what to do with it. I can synchronize it with my DOM, and I will synchronize DOM with your state. Basically, Angular saw that as an opportunity, and now it also provides, let's say, two-way binding native signal support with model. So we can say model, so read-only count model. And of course, it's a signal, so we can just call it. It's a signal, a writable signal, so we can also update it, so-called set or update on it. And of course, when we use it like counter, we can just use two-way data binding with it. And of course, that count is the same count name, that variable name that we use there. And then we can just provide another signal, a writable one. So what we can see here is basically that we can use signals, writable signals, give it to the framework, and the framework will know what to do, when to update, and how to update it. And of course, everything else works as normal signals with computed and effect. And don't forget the effect that always updates our state. So not just updating the view with signal state, but also updating our signal state with a, let's say, DOM state. Basically, Angular embraces two-way binding to the fullest. It says, give me everything where I can write and I can read, and I'll just make sure that everything just works. You don't have to care about change detection issues anymore. So let's build on top of DI that we saw before and some signals. So I have to say, most written code is glue code, basically connecting pieces together. So let's connect signals on RxJS. How many of you have used toSignal? Man, good. So this is a simplified internal view of how it looks like, but we can see one core thing. We have inject DestroyRef. We create some state. So we say a source signal with some initial value, if you provide it. We subscribe to some external word, which in our case is our observable. So we subscribe to observable and set the signal state when it updates. We clean up with DestroyRef, as we saw before. Cool. And then we just return something, in our case, a signal, which is reactive, meaning that wherever we use it, it just works as all the other signals. And of course, if we have an observable, I don't know, get user ID, we can just put it inside a toSignal, and it will give us signal value out of it. So basically some glue code to bridge two different worlds. So let's build. What are we going to build? Well, a route param and a query param. Let's see how we can use some of these to, let's say, simplify code. So let's use glue code to create more glue code. So we have a route param. We can say const route, inject activated route, That's where we get our query params mostly, inside our components or services. We say return to signal, and inside of it, we say route param. And inside the pipe, we do some transformation. In our case, we just get all the params object and give it the param name, param key. And that's it. Now, what we can do is the same thing for query param. So we have to signal, and inside of params, we use query params field inside that activated route. And in order to use it, we just say user ID equals route param, and we give the param key that we care about. Same thing about search query. We call query param, and that's it. Now we have a signal. We don't have to do the conversion from activated route params that is an observable to some signal, so we can use it, I don't know, inside some resource or Rx resource, or inside some effect, or get some state from URL to make an API call to get our user details. You just put a line there, and it's just supposed to give us everything that we need in a signals forms. Cool. Well, there are also other one-way derivation utilities. For example, resource. Resource just does the same thing. We can say resource. It accepts some parameters like ID, which is a signal, of course. And the loader, which will basically be our derivation logic. But all of this is one way. So we get some data, and that's it. And we can read it like value is loading, has value and error. So we saw how we can build with DI signals. Now let's also add some synchronization into it. So built-in synchronization tools, signal forms. That's what they do. Yeah. So if we have a signal, a writable one, we can just give it to our form function, which accepts a writable signal. And that form function will provide everything else, like value, valid, read-only, messages, errors, everything else. And synchronize them with a template. And also when template changes, it updates our filters form signal, that is a signal form. And our signal form, the moment that it changes, it tells the parent signal, in our case, this.filters, that it updated, and also updates that one. So it's basically doing two-way binding between your signal and the DOM. And you don't have to care about it, because that's the best part of signals. It just synchronizes themselves. So can we have query params with two-way binding support? Of course. So there's a library called ng extension. I work on it, and it has a function called linked query param. What does it do? This is simplified internal view. So inject activated route, DestroyRef the router. We do state subscription cleanup, so get the signal source, create one, then do a subscription to query params, get that state, and also register the onDestroy to unsubscribe. Then we have update and navigate, a custom function that we update the outside world, tell it how this signal can be updated, or the outside world can be updated. So we just do a route navigate, empty array, so it doesn't change the current path, just says update this fixed query param with this value, keep all the other things unchanged. So basically, query params handling merge. And of course, what we can do is we can override the original source signal and set method and the update method to use our custom method. And of course, that's the whole code. But that's a simplified internal view. It does much more than that. It's like two-way binding, parsing, stringification, built-in parser, default values, call lists, updates, whatever. Global configuration, dynamic keys, source signal integration, automatic synchronization, initial value from URL. And it's easily testable because it just uses activated route. So you're just testing signals in the end and your router state. We can use it like link query param search. It gives us a writable signal. And that's usable everywhere, in your forms, in your models, in your signal state, signal store, anything that accepts a signal, that thing will just work. We can parse, of course, param to number, or with some default value, or to Boolean, or to some array. We can use it in an Rx resource. We can say request, this is search, this.search, this is page, this.page, and do, I don't know, get to-dos. Okay, some demo time. What I have here, flights application, of course. So as you can see, I can refresh. It works, so it's not a video. Yes. So I can click show filters. it shows filters. I can hide filters, it hides filters, right? But if I want to keep the filters open, I want to update my state here. So whenever I send this link to someone else, because it can also have pagination there, I want that state to be in the URL so my links can be shareable easily and retain that UI state. So what I can do, I have this show filter signal. So show filter set, hide, otherwise normal signals. What I can do is say I want a linked query param that is bound to show filters. I want to have also some parsing because I want to use a Boolean there. So I can say parse, param to Boolean, and of course my default value should be false. That's it. I didn't touch anything else because everything else, it's a writable signal, it's normal signal state. I can just come here, click show filters. I have a query param now. Same thing here. If I refresh, just stays open. So basically it's synchronized with the router. What else can we synchronize? I see that we have this dark mode filter here. So I have to do something like that in order for it to work. So if I have my application open in two tabs, if some state changes in the other, that is also crucial for the other tabs that I have open. I want to synchronize them, and I can use local storage for that. So there's another function in ng extension called inject local storage. So what I can do is say inject local storage. I want to have light, of course, as my default value. And I want to link this to some, I don't know, theme mode as a key for my local storage. I can save. I can go to my site. I can just change local. And basically, it synchronizes not just the signal with the local storage. It synchronizes the signal with every other tab that you have. OK, what else can we do? Well, just like we have dark mode, I also want to synchronize my filters. I have filters, which is a writable signal, right? And I have local storage that I can use to synchronize between tabs. What I can do is go to my flights, comment out my code here, tell the application to store my show filters in local storage with some parsing for Booleans with some default value of false. OK? And at the same time, I can say, please link this signal to the query params. So I can say parse param to Boolean, and source should be these .show filters. I can come here, refresh to make sure everything works. I can hide filters, and I can hide filters in both pages at the same time. So basically, having synchronized state for everything, and that's what writable signals and signal synchronization does. And that's so cool. Thank you. If you want to know more about all these signals with custom change methods, or if they should have a set or update method or other ones, there's an open issue that you can check in Angular GitHub repository. You can leave your comments there. And if you need more features, well, ng extension is an open source library, MIT. It's feature-rich. It uses all the modern Angular features. It's extensible. Everything is tested. I don't know how many tests we have. And of course, tree-shakeable. If you use one function, you only import one function, nothing else. So completely tree-shakeable. And of course, there's a lot of signal utilities, router utilities, injectors, and other cool stuff. Lately, it reached 51K weekly downloads. I'm proud of it. And I'm proud of all these people working on it. So I want to thank all of them. And that's it. I'm Enea Jahollari. I work at Push-Based. I'm a software engineer. I do training, consultancy. Most of the time, these days, I improve web performance, architect Angular apps, and scale Angular with NX. If you have any questions, please just ping me. If you will need the slides and not pictures that probably may look bad, you can scan that thing and, I don't know, have fun playing with all this new Signal stuff. Thank you very much.